ISIS configuration. Let's get oriented. You can see from the topology on the screen we have 6 routers divided into 3 different areas. Now, if you're like most people getting into ISIS, you have a background in OSPF. So let me start there as a comparison. Normally in OSPF, we're used to starting off with area 0, the backbone area, having a bunch of backbone routers, and that grows and grows and grows until your database, your link state database, gets too big, and then you branch into multiple areas. So you introduce these routers known as ABRs, area border routers, which allow you to bridge area 0 into another area, area 1 in this case. And you've got all these routers that you start bringing up in area 1, which have the full database for area 1 and whatever summarized routes this ABR has been sending from area 0 and whatever other areas you have connected to that backbone area. So these are kind of schizophrenic routers. They have kind of a foot in each area. It's not how it works with ISIS. In ISIS, the routers are completely within their area. We've got PE1 and P1 sitting here. PE1 is a level 1 router fully in area 51, meaning it has the level 1 database and all of the routes, the full topology or link state database that we have for area 51. It would be the same way as, quote unquote, area 1 over here with all these different routers that would exist inside here. And that comes up to P1. This router is a level 1/level 2 router, and yet completely in area 51. It's not between areas like we have in the OSPF world. The difference is this guy can speak and form a level 1 neighbor relationship with PE1 and know the routes within area 1 or area 51, but also have a link over here to area 10, which I guess we could call it the backbone area, but I want to stay away from that because that's very OSPF languagey, to really every router that has the level 2 database, this guy, this guy, this guy, this guy, they are all backbone routers, meaning they have the summarized or hopefully summarized routes that you've injected in the backbone. The difference with ISIS is we can start wrapping this backbone around. We can have, area 10, which is what these guys are in, wrap around all the way over here with these level 2 routers. And we could start connecting areas over here, areas over here. I mean, so it kind of bends. I guess that's the best way I can say it. In OSPF, we've got this central core that everything connects to. M-I-C-K-E-Y. Central core that all these things connect to, and it's inflexible. Whereas in ISIS, you've got this bendable backbone that can kind of stretch and go wherever you stretch these level 2 routers. Now, let's be real. Most people use a hub and spoke topology like this. Think about our service provider diagram we've been using in this series. Everything always comes back to the service provider core, but ISIS allows you to extend that service provider core all around and bend it wherever you need it, and so that gives it more flexibility than OSPF. Okay, that's just our orientation, right? We're here to configure ISIS, so let's get started there. Well, I'm going to start off on PE1. We'll go with the little guy first, the one connecting to the edge network, maybe our customers, something like that. So I'm sitting on PE1. I'm going to go into privilege mode, just do a show IP interface brief to get us oriented. And we can see here that we've got the basic interfaces 10112 serial 0/0/0 connected up to P1, as well as a loopback just to simulate that test network over there on the right-hand side. First things first, global configuration mode. I'm going to type in router ISIS, which allows us to kick off the ISIS routing process. Now, if this were OSPF, which, again, most people are familiar with, you would type in a tag here, right? And that would be a number. Wait, it's not a tag. It's a process ID, right? Process ID is a number between 1 and like 4 billion. Everybody uses 1, right? Well, we see in ISIS, we've got a ISO routing area tag. What's that? It's anything you want it to be. You just have to remember what it is. I could go in here and name it Jeremy, and as long as I then reference the ISIS routing process as Jeremy and all my other configuration, it'll work just fine. But let me give you a tip. You don't want to do that. Just hit enter. Essentially, that creates router ISIS with a blank tag. Unless you have some very weird reason for running multiple ISIS processes on your router, which maybe in a virtual router instance scenario you might do that. But for the most part, if you're just running ISIS on the router as a whole. Just one tag works fine, and we'll call it a null tag, a blank tag that's coming in here. Now we come to our first major task. It is to assign the NSAP address. What's that? Well, remember ISIS runs the OSI protocol. Or let me back up and say ISIS was based on the OSI protocol, right? So all of its communication uses OSI addressing, and this is what we need as a NSAP address. Matter of fact, a lot of times this is also called the net address. So I'm going to type in net, and you can see context-sensitive help isn't very helpful here. It's like XXXXXX. Yeah, just go ahead and, I mean, if the first time you've seen it, you're like, so this pattern, I mean, is it like Morse code? What is this? This one address defines many things. One, it defines that this is a router, right? So there's certain identifiers in the ISIS or the OSI world that can identify different kinds of devices, an end system, a router, or an intermediate system, and all that kind of stuff. You can identify what router this is, essentially give it its OSI address, and give it its area ID. So right about there, I'm sure you're scratching your head going, what are you talking about? Let me show you. I created my own slide just for this concept, NSAP addresses. The original OSI protocol defined 5 fields the address would represent. Meaning, this is a little bit different, right? We're used to IP addresses, which is like 1.1.1.1. They don't mean anything. I guess you could say when you combine it with a subnet mask, you go, okay, well, this represents the network, this represents the host, right? I guess that would be a good comparison, right? So we have 2 distinct pieces of this address. Well, in the OSI world, when they created that protocol, they said, well, there's going to be 5 different things this address can represent. Meaning, just by looking at the address, you'd be able to tell all these different things about the devices connected to the network. Which, can I just digress for a moment? Nowadays, we would be like, that's awesome. It gives you so much flexibility. But back then, we're talking 1960s, 1970s time frame. People are like, why would we need that much flexibility? I don't know, Jim. Let's go with IP addressing instead. It's so much simpler. So OSI actually had so much more future forethought, goodness all about it, but we chose not to. Nonetheless, Cisco's implementation of ISIS only uses 3 of those fields. What does that mean? When you look at an OSI address in the Cisco world, you will be able to tell what area the device is in. Now, when I say device, I'm talking about just routers in this case, but can we go back to the original vision of whoever created OSI? They said we have these routers, which they didn't call them routers, right? This term router, who knows who came up with that? They called them intermediate systems. And that's why the routing protocol makes so much sense. ISIS, and it's like, oh, that's why they called it ISIS, is because you're passing packets from a router to a router. I get it, right? So ISIS is intermediate system to intermediate system, but there was a whole other routing protocol called ESIS. Anyone have a guess what an ES is? An end system. ES. So when OSI was originally created, even the end systems ran a quote-unquote routing protocol that allowed them to find their closest default gateway, is what we would call it in the IP world. Come on, who's with me in saying we need ISI? So we should have gone with the OSI protocol so many moons ago. Anyway, I'm done with that soapbox. So just by looking at a device's address, when we look at an IP address, we see host, and we see network fields, right, based on the subnet mask. Just by looking at the address in the OSI model, or OSI protocol, I keep saying that, we would be able to tell what area a system was in, and that would have gone for the ESs as well as the IS. What system it is, this is as close to the IP address concept as we had before. And then the NSAP selector, meaning what kind of device are you? Now, in our world, this is always 00, which means I'm a router. I'm an IS. But you would have had other things if we would have had, ESs and everything else. So here's an example address to look at. This is an example NSAP address, or what we were just about to type in there as the net address, right? The best thing that you can do is read it from right to left. Let me show you, and then I'll explain why I did that. Right here is what I would call the end cell. What kind of device is this? it's always 0, 0, meaning this is an intermediate system. It's a router. From there, we have the system ID. Looks like a MAC address, right? That identifies this system. It's essentially the address of the system. It has to be unique, if you will. Let me just put sys ID. Then we have whatever's left over, which identifies the area. So I guess technically you could say this is in area 49.1234. But most people would just say this is in area 1234. Why drop off the 49? Because 49 is what everybody uses in ISIS, because 49 represented a private OSI address. Yeah, they had that same concept for OSI just like they do for IP, private and public addressing. Well, all the private addresses of OSI started with 49, so you would see, so you'll always see 49. So what does this mean to us? Now, why did you go right to left? Well, it's because Cisco created these rules of the game, which help us a lot. These addresses in the OSI world can be 20 bytes in length, up to 20 bytes in length. So huge addressing. Remember, this is what we're seeing with IPv6. Is there, IP is kind of catching up to what OSI had envisioned from the very beginning. So if it can be that long, which is tremendously huge, right? We don't know, this could be, we could, that's why when we looked at this configuration, it's like, yeah, just keep going. 20 bytes is a whole lot of numbers in the hexadecimal world. So here's the rules. Can be up to 20 bytes, but we know that the last byte of the address is always 0, 0. I mentioned that, representing an intermediate system, representing a router. Likewise, Cisco made it a little easier for us because they said the system ID will always be a fixed 6 bytes in length. That's essentially why it looks like a MAC address, right? Now, that's not the rules of the game for everybody else, but for Cisco it is. And I'll say most vendors that implement ISIS follow that rule as well. So we know that we've got 1 byte right here, the next 6 bytes, which is going to be exactly this size, because each one of these octets, and I know it's not an octet, but each one of these things with hexadecimal represents 2 bytes. So that's our 6 bytes right there. And then whatever's left over after that represents the area. So you could have an area that's like 53.29.63.92. Goes on and on and on. But most people use area IDs like 1, 10, 50. Whole numbers that make sense in our heads, right? So coming back to that original diagram, we see area 51, but if we were assigning this, and actually we will in just a second, as in an NSAP address, it would actually be 49, meaning it's private, 0051. Dot, and then everything else after that, right? So let's actually get back to that configuration with PE1. We've got this XXXXX network entry. So I'm going to type in net followed by 49.0051. Now I'm going left to right, which is not how you read it, but there it is, dot, and then I'll put in the system ID. What do I want it to be? How about we do this? 1111111111. Right? Just because it's the first router I've configured, it has to be unique. So, for instance, I can't replicate that over on P1. I'll have to be a little more creative when I get to that. Dot, and then what's the last piece? It is the end cell, which is 00. Always 00, representing this is a router. Enter. Yeah, I know. So that command right there. That command represents why 99% of the world doesn't use ISIS. It's because they don't get it. They look at that and they go, what does that mean? That is an OSI address, and that's all you need. It's not like an IP address where I have to go on this interface, I have this address, on this interface, I have this address. This represents the router as a whole in the OSI stack, and it will be its identity for this ISIS process, right? That's it. Okay, so that one command has identified what system it is, what area it's in, and that it's a router in no particular order. Now, we go under interface loopback 00, or loopback 0. I'm thinking module or loopbacks. And I'm going to add this to the router ISIS process. This is very similar to what we did with OSPF. We can either, in OSPF, use the network command under the routing process. Well, can't do that with ISIS. We actually go the easier route under each interface and just type in IP router ISIS. Bam. I've now added that loopback interface to the ISIS routing process. And Hang on, before I add the serial interface, we saw we had serial 0/0/0 up there. Before I add that in, I want to make sure that this guy doesn't form any unnecessary relationships. The default state of a router is it will be a level 1/level 2 router, right? So that means that it will try to form both relationships on every single link that you add to it. So I'm going to change that. I'm going to go into router ISIS, back under there, and type in IS type, hit the question mark, level 1. Meaning I'm only going to maintain that level 1 database. You can see right below is the default level 1-2, so it does both inside and outside router. And then this is interesting to me, level 2 only, act only as the, I don't like these descriptions, an area router only, essentially a backbone router, have the backbone database only. My question to Cisco would be, why did you have level 1 and then level 2 only? Do you feel the inconsistency there? Why isn't it level 1 only and level 2 only? Or level 1 and level... Anyway, my own little inconsistent gripe with Cisco there. So this is now defined as a level 1 only router, so it will only form level 1 relationships. Now I'm okay. Now, it wouldn't have formed a relationship yet because we haven't configured the P1 router anyway, but I'll go under serial 0/0/0 and I'll type in IP router ISIS. Now, both of those are added to the ISIS routing process. Okay, good. So let me now go to, let's just go on the fast track, configure PE2, and then we'll jump over here and configure P1 and see some neighbor relationships forming. All right, PE2 is live and in the game. I'll do a show IP interface brief, very similar to PE1. Looking good. So I'll go into global config mode, router ISIS. We'll do that net command, and we will put in, what would that be? 40. So we're in area 50 down here. So it would be 49 private addressing dot 0050 dot, and let's just go all twos with this guy. That's its system ID. Dot, and what's at the end? 00, right? That tells it is a router in the OSI addressing model. So we've identified the net, and while we're here, we might as well just do this. IS type level 1, because this is also a level 1 only router. Now I'll go under my interfaces. Interface loopback 0, IP router ISIS. Interface serial 0/0/0, which is that interface, IP router ISIS. Okay, good. So now we've got PE1 and PE2 configured. Let's now get to the provider routers, P1 and P2. P1 has entered the scene. I'll do show IP interface brief on this guy. We've got serial 2/0 connecting down to PE1. And then we've got fast Ethernet 1/0 connecting over here to the core. Those are our iOS XR routers. So global config mode, router ISIS, just like before. By the way, if you do use a tag there, it's not like an autonomous system to where it has to agree between the sides. It's like OSPF to where it's all local. You just have to remember what tag you've used. Okay, so I'm under the router. I'll do the net command, net 49.0051. So it's the same area as PE1. Right, but now I need a different system ID. Let's go 1111.5151. 1111. Just, again, making it unique. Dot 00 at the end there. IS type. Actually, I don't need to change this because level 1-2 is the default, so we'll just leave that at default. Bail out of the router configuration mode, and I'll go under interface serial 2/0, and we will do IP router ISIS, right? We've turned it on. Now, this will only form a level 1 relationship because why? PE1 over here is a level 1 router. So it's remember, with ISIS, we talked about in the concepts, level 1 and level 2 are as different as oil and water. Essentially, they have their own hello messages, they have their own neighbor relationships and everything like that. But when I turn this on, I said you are a level 1/level 2 router. It's going to send hello messages for level 1 and hello messages for level 2 out here. Now, this guy's only talking level 1 back. So he's going to say, hi, level 1, form that neighbor relationship. So that's okay, but why say hi if you're not going to form a neighbor relationship there, right? So I'm going to come under here and use a new command up till now. ISIS circuit type and then tell it what kind of hello messages it should be sending out. So this circuit, this interface, is going to be a level 1 interface only, meaning now I've cut off that excess hello traffic for level 2. Okay. Same thing down here. I'll go under interface fast Ethernet 1/0, which connects back to the core. I'm going to do on this one IP router ISIS, but on the flip side, this is the level 2 side of it, so why waste hello messages on level 1? I'll do ISIS circuit type, and we'll do level 2 only on that guy, right? Okay, now let's do some verification. At this point, my guess is that P1 has formed a neighbor relationship with PE2. Probably not on the core side. Well, I hope not, because I haven't configured that yet. So I'm going to do a show CLNS neighbor. Now, what's CLNS? That's, again, OSI language, OSI addressing. What kind of OSI neighbors have you formed? And it comes up and it goes, hey, I've seen PE1. Sweet. So we can see that it's working. I've formed this neighbor relationship on serial 2/0. Now, what is SNPA? SNPA stands for Subnetwork Point of Attachment. No, you won't have to remember that. Essentially, it's saying what layer 2 address are you using when you're communicating over to PE1? So if this was a Ethernet link, you would see a MAC address in there. If it was frame relay, you would see a DELC number in there. If it was an HDLC link, you would see HDLC sitting in there with the asterisk behind it, because HDLC doesn't use level 2 addressing. I keep saying layer 2, like layer 2 OSI model, right? Layer 2 addressing, it just kind of sends stuff because HDLC is so simple. But we've now formed, look at that, type level 1. Are you seeing it? Are you getting that warm and fuzzy feeling? It's good. It's good. It's not, see, once you get used to it, you're like, this isn't so bad. I'll do a show neighbor detail, and you start seeing some of the concepts that we've seen play out. It goes, this is an area 490051. How did it know that? From the net address, right? What is the IP address? Now this, you notice this little star. What's going on here? What this is saying is, hey, this isn't ISIS's game. Right? Somebody's tweaked something, because ISIS is all about OSI relationships and OSI addressing. So this says I'm using integrated ISIS to do this. So I see the IP address of my neighbor. I see its uptime. I see the interface that it's going out. How about show CLNS interface? See what interfaces are running ISIS here. And we can see fast Ethernet 0/0. Oh, I was like, that's a problem. Well, I'm not using that interface. It's down, right? Fast Ethernet 1/0 is up, and I can see going down here, it's sending a routing protocol ISIS. It's saying next, notice ESH or ISH, that's end system hello or intermediate system hello, due in 29 seconds. What kind of circuit it is? Pretty good, huh? I mean, without going line by line by line, you're getting the idea of this. Level 2 messages being sent out. It's good, right? Down here, I see this is a level 1 relationship only. Matter of fact, on that serial interface, I see I have a level 1 adjacency that's formed. I see my neighbor system ID that I've formed on that. So we can verify a lot with that show CLNS interface. I'll even do a show CLNS, just hit the enter key. And this just gives you a general feel of what CLNS relationships we formed, shows you the net command that you've entered on here. It's saying this is IP only mode representing integrated ISIS. We're not really forwarding CLNS. We're not really forwarding OSI traffic or anything like that on these interfaces. So a lot of after all this, I'm like, woohoo! We haven't even looked at the routing table. Let's do a show IP route. Dope! Wait a sec. Show IP protocol. Did I leave OSPF running? Did. All right, no router OSPF1. I used the same routers that I used in the OSPF demonstration, so let's kill OSPF, shall we? Let's just make sure we do that on all of them. No router OSPF1 or ISPF. That's my own protocol. OSPF1, kill that guy, and lastly, no router OSPF1. So OSPF being gone, and just as a demonstration, that's how you turn off OSPF. I'll do a show IP route again. Now we're good. Now, notice why did we just see O's everywhere? Well, because OSPF has an administrative distance of 110, so it had a conflict here. ISIS has an administrative distance of 115, so it's not as desirable, at least from Cisco's perspective, who created that little table for their routers, as OSPF. So now that OSPF is gone, ISIS, the little I, ends up winning, and you notice that this is in the level 1 database, right? We've learned our first route from the provider's perspective. I now see the test network over there on the right-hand side. Good, good, good. All right, let's fly through the P2 configuration, then we'll get to the core. Sitting on here on P2 now, global configuration mode. I like doing the mirrored because I get to go through it quick without the lengthy description. It just solidifies the concept even more. So router ISIS, let's add the net command, get this guy configured from actually, let's do this. No router OSPF1. I could see that coming back to haunt us. Okay, now router ISIS, and we will do the net command of 49.0050, area 50, right? And we'll go 2222, let's go the same scheme we did above, 5050, 2222.00. So essentially this guy's OSI address is 2222.5050.2222. It is a router, it is an area 50, right? Hit the enter key. That's all I should need for this configuration mode because it is a level 1/level 2 router. Okay, I'm going to go into serial 2/0. We'll do IP router ISIS. Enable that relationship, and let's do ISIS circuit type level 1. Enter. Then we will do interface fast Ethernet 1/0, which is going back to the core here on the other side. And we will do IP router ISIS and ISIS circuit type level 2 only. Good? All right. Good, good. Let's do a show CLNS. That was totally nothing that it was supposed to be. CDL, I don't know how I typed that in. So CLNS neighbors. I've got my neighbor relationship. I see PE2 over there. Let's do a show IP route. Should be no OSPF routes. We just see the level 1. Because P1 and P2 don't have a direct link, they're going through the core. We only see the one route that is learned so far. Now let's get to the iOS XR. Got our big Mamma Jamma router sitting in the middle of the screen. Let's go global on this guy. We'll do no router OSPF 1. Commit. Get that guy disabled. Turn off. Disable that neighbor. Now we'll go into router ISIS. Actually, on iOS XR, they don't give you the option of that null tab. So I've always wanted to. Let's use Jeremy. I'm going into router ISIS Jeremy. We've got to remember to use that tag if we reference it elsewhere. However, you're going to see there's not much need for that on iOS XR. So same thing as before, we're going to need that net address. So we'll type in net 49.0010. Why? Because I'm in area 10 over here that I've put these guys in. So area 10, we've got dot, and then we'll just go 1111, 1111. This is router 1 in area 10, so that address can be the same as previous, and then we'll go 00, right? And let me make sure I clarify. That's not the same address, right? I'm just saying the system ID can be the same as what we used in another area, simply because we're in a new area, so the address as a whole is unique. Okay. Now we see some differences. Well, first off, let's see what's the same. IS type, this is the same as before, and they didn't change it in the iOS XR. They still have level 2 only, and now we get to use it. These guys are backbone routers only. Now, instead of going out, and this is similar to OSPF, instead of going out of the router configuration mode and into an interface, I'm going to go right into the interface in here. This is interface under the router config, G0/1/0/1, and this is the one connecting from core 1 over to provider 1, right? So I'm going to then say, and this is something unique to the iOS XR, address family. This is what address family do you want to run? Now, this is the only thing that you have to do to turn on ISIS, is say, I'm actually running this for IPv4. Now, you're under address family mode, and you can type commands under there, but that's it. Now, if you run it for IPv6, you can do that as well, or whatever other protocols this flavor of the iOS XR supports. I mean, if you have CLNS that you want to be able to run, if you're running OS, I mean, multicast, there's all kinds of different address families. For ISIS, we just have IPv4 and IPv6, but we don't need that IP router ISIS command because we're already under the ISIS configuration right here, right? So then I'm going to go back under here, and I'll say bail out of the gig 0101, and I'll do interface gigabit Ethernet 0102, which is going to be this link here between core 1 and core 2, and I'll do address family IPv4. That's kind of like your IP router ISIS command, turning it on for the IPv4 family. Exit, 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 and commit. ISIS is now running on this router. Now, in here, we have a few different show commands. I'm going to do show ISIS adjacency. You can see I've formed an adjacency with P1. Now this subnetwork point of attachment, this level 2 addressing, makes sense because, oh, it's a fast Ethernet address. It's got a MAC address, so that's what I'm communicating with. I see that this is in a state of up. We are forming a router relationship. I'm trying to think, what other cool new info can I add here? Let's just do a show IP route, or I'm so used to that. Show route IPv4, and we'll do, let's hit the enter key. Right? Look at this. We've got routes now coming into the level 2 database. What are these? These are essentially the WAN link between P1 and PE1 and the test network over there. Now, wait a sec. You're like, aren't those in the level 1 database? They are. How'd they get in the level 2 database? It just does that. By default, the level 1/level 2 router will take whatever routes it has in level 1 and pass it up to level 2. That's what it does. It's the same thing with OSPF. We've got area 0, right? Just because I put an ABR there and say this is area 1 doesn't mean it like puts a wall and says, okay, area 0 routes aren't allowed over here. It can still do that. It's just now we have the ability to summarize, right? That's the whole idea of the ABR, is it has the summarization capability. And the same thing here. Level 1, level 2 routers have the ability to summarize as you take those routes from level 1 and put them into level 2. I'll show you that in just a sec. For now, let's go down to C2. Large router number 2. Global config. No router OSPF 1. Commit. Get that out of the way. Then we will go to router ISIS. Router ISIS. Let's just do Bob. Why would you do that? Because you're doing a demonstration. I'm going to go net, and we'll do 49.001.0.2222.2222.2222.00. This is a router. Are you really getting the feel of this? I mean, it's not too bad, right? Once you start doing it. IS type will be level 2 only, right? Because this is, again, backbone router. And we could, I mean, you could go in and even do the circuit type if you wanted to under the interface to kind of back yourself up, but why? It's a level 2 only router. It's only going to send level 2 hellos. So interface, and on this one I am doing show IP interface. Brief. Different interfaces. So I'm going to do interface GI 0/4/0/1, which is the one connecting over here to P2. I go under that interface configuration mode, and I will do address family IPv4. See that? So as long as we're doing it under the ISIS routing process, interface 0402, which is the one connecting between the two core routers, address family IPv4, exit, 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 commit. Good. We now have ISIS up and running. Let's do a show ISIS adjacency. And we should see, yep, there we go. P2 and C1, both of them with MAC addresses. And you can see the ISIS is starting up, but we're already there. And we can do a show route IPv4. And we should see the level 2 database being full of all these different routes, which totally inefficient, but you get the concept, right? We're just passing routes from the level 1 areas into, or I should say the level 1 databases of the areas into the level 2 database. So what would we want to do? We would probably want to summarize. How do you do that? Well, you're going to go to the level 1/level 2 routers and just use a summary address command. Let me see if I can find them here in the list. Let's just grab P2. What's P2 showing? He's got 192.168.2 over there. It learned from his buddy. So I don't really have much room for summarization because each one has like one route. But let me just show you the command. We go into router ISIS, right? No tag in this case, and just do summary address. We would say summary address. Let's just do 192.168. Like, how do you summarize? Let's go 00 with a 255.255.00. I mean, we could really mess something up doing this. And then we're going to say this is going to go into the level 2 database, right? What it will do is automatically suppress whatever routes are more specific, and you can set metrics, you can set tags and all that kind of stuff. Whatever more specific routes you have going in there, it will suppress and replace it with this summary route, right? That's all there is to summarization. Now, you don't even have to put level 2 on there because that is the default. Cisco knows that most of the time you're going to summarize going into that direction, but they let you go whatever directions you want with that. Last thing I want to show you. I'm going to exit out here and do a show IP route. Notice something funny about these metrics. Yes, 50, 20, 30, 20. They seem unbelievably even. And you might remember that when we talked about the metric of ISIS in the concept nugget, by default, every interface has a metric of what? 10. So it's no better than RIP out of the box. It just kind of is like a hop count, but uses 10. So before you go anywhere in ISIS, you want to remember, in the same way that we remember to set the bandwidth of the interface for OSPF, you want to go under the interfaces themselves. We'll do interface, serial 2/0. And let's just say the metric for this one, and the command is very straightforward, ISIS metric. And then what do you want it to be? You can go in there and set whatever metric you want. Now, some iOS versions, older iOS versions, will only allow you to set a metric from 1 to 63. Newer ones will allow you to have whatever metric in this range that you want because they expanded how many bits it can end up using. But to be safe, if you have older routers, stick in the range of 1 to 63 so that you're compatible with the metric of all of them. Now, this is where you would have that spreadsheet, right? You would go out there and say, well, actually, it wouldn't be 5 because 5 would be a very good one. We'll say it's a T1 line. It might be 35, right? And that now adjusts that cost, but you have to be consistent. So you've got a spreadsheet showing all the different bandwidth values in your system and what metric they would be assigned. Well, my friends, ISIS configuration in all its glory. I hope this has been informative for you, and I'd like to thank you for viewing.